Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into a truly fascinating project, a capacitive touch keyboard business card. It's incredibly ambitious, and the creator, Ricardo, has documented the entire process meticulously.
Yeah, I saw this on Hackaday. A business card that's also a fully functional keyboard? That's next level stuff. What microcontroller did he end up using?
Initially, he considered the RP2040, ATmega32U, and STM32F103, but they lacked native capacitive touch. So, he smartly switched to the CH32V303, which has built-in USB 2.0 and 16 capacitive touch channels, enough for a 40% keyboard via multiplexing. But then, to keep costs down, he went with the CH582M.
Wow, a cost optimization mid-project. That's impressive. What about the challenges? I bet there were a few.
Oh, absolutely. He encountered a major GND connection error on the initial PCB. The exposed pad of the microcontroller wasn't connected to the GND plane. A quick fix was needed there. He also learned that adding indicator LEDs, even a simple power LED, would have been beneficial, despite the initial cost-cutting measure, and the PCB thickness was a bit off, leading to a loose USB-C connection.
A loose USB-C connection on a business card keyboard? That sounds frustrating. What about the software side of things?
That's where it gets interesting. The CH582M doesn't play nicely with the Arduino IDE, so he's using Mound River Studio. He's already gotten code running, but there's still a lot of firmware development to do. He's also added a wireless antenna, leveraging the COVALENTC1H582M's Bluetooth capabilities. It's a really ambitious project.
Bluetooth on a business card keyboard? That's insane. What's the total cost? I'm curious about the economics of this.
Incredibly cheap. Around $1.50 USD for all the components. PCBWay sponsored the PCBs, which is a huge help. The whole thing is open source too, with schematics and firmware available on OSHW Lab and GitHub. It's a testament to the power of open source hardware and clever design choices.
That's amazing. But there's a comment on Hackaday.io pointing out that it might not be fully functional for all international keyboards, missing Alt-GR support, for example. That's a significant limitation, isn't it?
You're right, that's a valid criticism. The current design might not cater to all international keyboard layouts. That's definitely something to consider for future iterations. It highlights the complexity of designing a truly universal keyboard, even on a small scale. But, given the project's scope and low cost, it's still an incredible achievement.
Absolutely. It's a fantastic proof of concept, showcasing the potential of integrating advanced electronics into everyday objects. The ingenuity is remarkable.
Exactly. It's a great example of how far you can push the boundaries of embedded systems design with creativity and resourcefulness. And a big thanks to PCBWay for their support. That's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.